Today what we're going to do is we're going to switch gears, and from now on we'll be using Java throughout the semester. And some of you have already seen something similar to this demonstration before, but I wanted to make sure that we were all on the same page and to remind you about tips and tricks with Eclipse. And also to go through and remind, as an introduction kind of to object-oriented programming, let's first start by designing some objects and what are some best practices for designing objects in Java. So there are four aspects of object-oriented programming: encapsulation, abstraction, polymorphism, and inheritance. And in CS1, we go through those first two, encapsulation and abstraction. But if you are only familiar with it with a weak or with a non object-oriented programming language like C, you only have weak encapsulation. Encapsulation involves actually three things: the grouping of data, the protection of data, and the grouping of functionality that acts on that data. And by the end of the day, we'll see how all three of these are achieved in Java. In a programming language like C, you only have the first one, which is weak encapsulation, right? The grouping of data. So the way that I'm going to do this is through tutorial style. Let's go ahead and design and implement an airport class, just a class that that models an airport. Okay. So first of all, I'm going to create a new. All right, let me refocus over there. A new class, right? And what should I call it? Airport. Should I call it airports? No. This is a blueprint that you can create instances of airports out of this. Like an airport for Lincoln, an airport for Omaha, an airport for whatever. You wouldn't look at blueprints for a house where you could take this blueprints and build 3 houses with the same blueprints. You wouldn't call that blueprint houses, right? You'd call the things that you actually build from those blueprints houses, right? So airport, good enough. So what constitutes an airport? How would I identify an airport? Yeah. Okay, like the company that owns it. Usually it's municipal airport, governments that own airports, right? There are private airports, of course. So think of the airport here in Lincoln. What is it? Yeah. Okay, so like what? What are coordinates on Earth? You say what? Latitude, and longitude. All right, why did I use doubles on those, by the way? What are latitudes and longitudes anyway, right? 48 degrees north, 48 degrees, 38 minutes, 42 seconds north, right? There's 3 components, but it's much easier to just deal with it as one number. 48.38 degrees north. Right? North is positive, south is negative, so 45 degrees south would be negative 45, right? You could also think about it in radians, and that's what we'll want to convert to later on. But latitude and longitude both doubles so far. What about the airport in Lincoln? How would you refer to that airport? A what? All right, a name, which is probably a string, right? Lincoln Municipal Airport, I think is what it's called. Over in Omaha, it's Epley Airfield. Chicago O'Hare. LaGuardia, right? Names. Right? What else defines an airport? Just to have a variety here, GPS ID. Right? Again, for those of you in 155E from last semester, you did this, and I think that these were, and then there are a few other things like types of airports. There's a heliport, a small airport, a large airport, right? But we'll go ahead and keep it simple. This is good enough for now, okay? All right, well, I have essentially achieved the number 1 of encapsulation, and equivalent to C, you are grouping data together. Now let's actually go ahead and use it. Airport demo. Right? So I should have created a main, public static void main string args. Right? Let's create some airports. Let's create Lincoln. Right? So airport. Now that I've defined it, just like a structure. Right? If I create a structure for airports, now I can go airport A is equal to whatever, right? Instead of int x is equal to, now this is a user-defined type. I can actually start using this. I'll call it Lincoln. Right? How do I create an airport, though? Is an airport created just by this line alone? No. What is Lincoln? What is this variable right now? What value does it have right now? Null. And to prove it, let's print it out. Oh, enum, public class. There we go. All right, and okay, it's not even letting me print it out. Why? Because when I print it out, what's going to happen? It's unresolved compilation errors. That it's null, right? In fact, it won't even let me do anything. I'll go ahead and set it equal to null, which is essentially what it is right now, right? But it's not even a compiler. It's not even a compilable program if you don't initialize it. Okay. So I won't do anything with it, but let's create a couple more airports here just so that we can see what it looks like. O'Hare. There we go. And this is an uninitialized object, right? So in most contexts, the uninitialized object won't even allow you. You can't use it. You can. It's compiling now because I'm not actually trying to do anything with it. It is a warning. In fact, all of these are warning that they're unused variables. All right. Well, I want to print out what constitutes the Lincoln Airport. Oh, sorry. Let's actually initialize it. So how do I initialize an object in Java? Equals new. I use the new keyword, airport. This is a constructor. Right? It is a very special method that we'll talk about more in detail in a second here. Before I do that, though, I want to focus more on encapsulation. So system.out.println Lincoln. Now, how do I access the member variables? These are all member variables. Right? I'm not going to leave that in there as documentation, but that's bad documentation. That's me demonstrating in a course documentation. But those are all member variables. How do I access those member variables? Yeah, what is it called? Hold on. That's what we'll do eventually. Just raw right now without the number 2 and the number 3 of encapsulation, the dot operator, dot name. If I print this out, what's it going to print? Did I initialize the name? Did I set the name at all? Nope, that's going to print null. So because if by default, right, by default a local variable has to be initialized before I use it, but by default member variables don't have to be initialized. But if they're not initialized, then what values do they take on? Well, for objects, it's going to be null. Strings are objects. What about for latitudes, longitudes? What if I printed that out instead? GPS ID, latitude, longitude. There we go. Oh, what are you complaining about? GSP. All right. GPS. Thank you. There we go. All right. What values is this going to print out? Null, null. What's the default value of a non-object? The small d double. It's going to be 0. Okay. There's no need to take up all this real estate, so let's go ahead and move you over here. There we go. All right. So 0 is going to be the default. Okay. Well, I actually want, Lincoln's information here. So how do I set them? Lincoln.name is equal to Lincoln Municipal. Is that how you spell it? Airport, I think. All right. Lincoln.GPS ID. I think it's LNK. All right. Lincoln.latitude is equal to. Do I have a web browser open here? Is there Lincoln Municipal Airport? It'll correct it for me. Latitude, longitude. There we go. What's its latitude and longitude? There. 40 degrees north and negative 96 degrees. In other words, 96 degrees west, right? So I'll go ahead and set it to those things. And Lincoln dot longitude is equal to that. All right. Now when I print these out, these have been initialized. Oops. These have been initialized, and it'll print it out because I've taken on those values. Wash, rinse, repeat for Omaha. Is that a good strategy? Copy pasta, copy pasta, copy pasta, 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 right? But what's the consequence there? Of course, new airport. That was intentional in this case, but what was the consequence? I forgot to change one of those, right? So this seems like a bad strategy. I will go ahead and go with this strategy for a second. If you want to be absolutely sure, instead of paste, 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 you can at least use a code block mode, right? We've all talked about that before, right? All right, so code block mode is going to be Command Option A. Right? I showed it to you with I just went into Eclipse, I think, last week, and showed it to you in the context of PHP, though. That's nice. It's a nice tool. Let's see. I think it's Omaha Epley, I think. Omaha Epley. What is it? Latitude and longitude. You can tell I looked them up before. Slightly more north, slightly more east. All right. So there it is, north. Just 2 decimals of accuracy is enough. And then there's the rest of it. Just 2 decimals of accuracy is enough. Right? Okay. And if I print these out, then I get Omaha Epley, right? So copy paste for O'Hare. Now, let's go over to airport. And what we're going to do is we're going to create our own constructor. Right? A constructor is a very special method in Java. It's in object-oriented programming. It's basically airport. It has special syntax in Java. And normally you would have, say, public int foo, right? And it returns an integer. The return type is specified right here, right? Is there a return type here at all? No, because it's a constructor, right? It's going to construct an airport, so you don't need a return type because implicitly it's going to build an airport, okay? So no return type. The other syntactical issue is that constructors always have the same name as the class. Otherwise, they're not constructors. If I say construct airport, then it does need a return type because that's not a constructor anymore, right? So airport. That's the constructor that's provided for you. Over here, remember, I had a default no argument constructor. It was provided for me, like a lawyer, right? If you cannot afford one, one will be provided for you. If you don't write a constructor, one will be provided for you in Java. And the default behavior, as we observed, was to assign null to all object references and to assign 0 to all numerical references. If it was an integer, it'd also be 0. If it were a Boolean, the default is false. And if it's a byte, it's going to be 0. And I think that's all the built-in types. Okay. So I don't want that, though. What I want is a constructor that I can actually construct these things, that I don't have to do this over and over and over again. I want to pass this Lincoln Municipal Airport, LNK, and these 2 numbers. I want to pass that into the constructor, and I want it to take care of it for me because I don't want to have to repeat that code everywhere. Anytime you find yourself repeating code or copy-pasting code, remember the DRY principle. What was that? Don't repeat yourself, right? Take that code that's repeated, put it into a function or method, and then call the method. So string name, string GPS ID, double latitude, double longitude, there we go. Not much typing, but I've got push buttonitis. Right? Did I talk about that last semester? No? You ever seen the old TV show, The Jetsons? Everybody's heard of it before, right? I think it was the first episode of The Jetsons. We're talking about the 60s. It's very dated, first of all, but it was supposed to take place in, I don't know, 2010, say 50 years in the future, where everything is done through buttons. So you want to make breakfast, all she had to do was push a button. You want to do the laundry, all you had to do was push a button, right? But pushing buttons, it started to hurt her finger. So not only was she not doing any manual labor, the last part of the manual labor, push button, push button. So their solution was to get a robot to push the buttons for them, right? I've got push buttons. I think they called it push buttonitis or something like that. So I don't like to type either. I want to get a robot to do all this for me. I'll show you that in a second here. All right. But first of all, we need to actually set these things. So name is equal to name. That is, I want this airport's name to be equal to the name. I want the GPS ID to be equal to this GPS ID. And latitude equals latitude. Longitude is equal to longitude. All right. Lots of warnings. Let's read. Can people in the back read that? Probably not. The assignment to variable name has no effect. What does that mean? Int x is equal to 10, x is equal to x. Would you ever write code like that on line 14 right there? No, why? What does it do? Well, it does something, but what does it do? Take the thing on the right-hand side and put it into the thing on the left-hand side. In other words, take the thing out of the box and put it back in the box. Right? And it's the same warning, that the assignment to variable x has no effect. Same thing here. There are two variables called name in the current scope. There's the parameter variable, and then there's this member variable up here. Right? And unfortunately, the way that I've written it is that this parameter variable refers to both of these things right here. All it's doing is taking the value stored in the parameter variable and placing it into the parameter variable again, right? I need a way to distinguish this name right here and this name up here. To do that, let's think outside the class and ignore this compiler error here for a second. I've got this object that represents the Lincoln Airport. Right? Now, in this class, in this demo class, I have a reference to it. That reference has a variable name called Lincoln. This is Lincoln right here. Right? It's kind of like a pointer variable because it's a reference variable. So from outside of the object, I have a way of referring to the object through the variable name. But now let's follow this reference and jump inside the object. Now that's our world. Do you see a way of referencing Lincoln? No, because this might be Omaha. This might be O'Hare. Instead, if I jump inside that object, now I need a way of referring to myself. Right? Or if I go to the Lincoln Airport and I'm standing in the middle of the airport, what would I say? I'm in the Lincoln Airport. Yeah, okay, I could still say that. But I'm in this airport. And that's what we use, this. We need a pronoun, right? I need a way to refer to myself. What pronouns do I use? I, me, right? If I'm an object and I refer to myself, of course, I have no identity, gender, or anything like that. I'm just an object. I'm just an airport, right? So an airport is referring to itself, right? So this, and of course, we can get this nice and quick by simply just doing that, right? There. Now, all those warnings are gone. I'm taking the parameter variable and I'm placing it into this object's variable's name. Right? I'm doing that on all of these. Now let's go back over to the airport demo here and we'll see, let's address that compiler issue now. Well, like a lawyer, if you cannot afford one, one will be provided for you. But the second that you can afford one, your public defender is off the case. So the second that you define a non-default constructor, the default constructor goes away. Right? You can always restore it. You can have as many constructors as you want. Public airport. There's the default no argument constructor. You can have a constructor that only does part of it. I don't care about latitude, longitude. I want a constructor just for the name. Right? And then it takes care of all the others for you. Right? I could have copy, paste. I could have another airport constructor here that does the name and the GPS ID, but not the latitude and longitude, so I could ignore that. DRY. Do you see a lot of repeated code here? Yep, a little bit. Let's clean it up a little bit. What's the most general constructor here? The one that takes all of them, right? This one that I'm in right here. So code reuse, if you only want to set the name, then why don't you call this one up here, airport, passing in the name, and then defaults for the others, null, 0, 0. Right? Or if you want to, you can have, it doesn't make sense to have a -1 default. I'll go ahead and keep them as 0 and 0 and 0. Right? There we go. That's not going to work. That's not a function. That's a very special type of function. It's a very special type of method called the constructor. How do I refer to this object's constructor? This. This is not the object itself. It's calling, because I've got parentheses there, it's calling the constructor on this object. It's simply calling this constructor up here. And I can do likewise with the rest of them. I won't do it with the default constructor here, but you can do it with this. Get rid of these and pass in GPS ID. There we go. GPS ID. There we go. All right. Now, let's roll back. Oh, by the way, you see that this goes away now. And how would we end up using this? Well, I do want to call that most general constructor. Let's refactor this so that I am not copy pasting everywhere, and I am calling that constructor. There we go. Likewise for Omaha. I'll call that Omaha Epley, Omaha 41.3, negative 95. There we go. There, much cleaner code. I've taken care of it all in the constructors. Now let's roll back and solve my push button itis. I don't want to type that stuff every single time. In fact, one of the most common criticisms I see of Java is that it's a verbose language. You have to have so much boilerplate. You get push button itis coding in Java all the time. Not if you do it right. Rely on your IDE. Right? So you can't see it because it's on the other screen here, but if you go up to source, there are a bunch of things like generate getters and setters, generate constructor using fields, and now you can see this up here. Right? I want a constructor with just the name and the GPS ID. Oh, well, I've already got that down here. Select all, generate. I didn't have to write a single line of code. Right? There. It took care of it for me. Good. Now, one thing that it generated that I didn't put in was the super. That's already called for you. You can debate on whether or not it should be explicit or implicit. That's going to happen anyway. I don't want to get into it now because that gets into inheritance, and that's another pillar that we're going to save for later. I just want to focus on encapsulation right now. At this point, I've basically repeated the functionality that you can have in C by using structures, grouping data together, by writing a factory function so that you can pass stuff off and allocate memory and set stuff up if you want. But one other observation here is in contrast to C is that they're all the same name. You can have methods, multiple methods with the same name. You can't have that in C because you don't have function. You remember what it's called? Overloading, right? I always have to remind myself, overloading, overriding, it's overloading. Where in C, you had to have 3 or 4 or half a dozen absolute value functions. One for integers, abs. One for doubles, fabs. One for longs, labs, right? Abs, fabs, labs, lalabs, and several others. You had to have a different named one each time because only a function can only ever have one name. Here we've got 4 functions with the same name. But the compiler is able to figure it out because the compiler says, oh, you are calling a constructor with 4 arguments. The first 2 are strings. The second 2 are doubles. Oh, you probably meant this one, right? So a compiler is dumb, but at least it can figure that out. It's called static dispatch, something that we'll talk about later. Okay? We've basically repeated number 1 of the number 1 of encapsulation. Let's move on to the number 2 of encapsulation. To demonstrate this, let me go ahead and break encapsulation by doing this. Lincoln.latitude. I set the latitude up here to 40 degrees north. Let me reset it to 4,000. Right? Is that a valid latitude? I mean, if you want to go around the planet 100 times or 10, 20 times or so, and then come back up to 40 times or 50 times, whatever it is, and then come back up to whatever is remaining. but that's not a valid latitude. Okay. What I want to do is I want the ability to control the values that are set in my class. I don't want just anybody being able to see it, because if anybody can see it, anybody can change it. And if anybody can change it, you need to test for the eventuality that somebody will change it. Right? And that is way too complicated, way too unpredictable. I want predictable code. So what I want to do is I want to control access to my variables through getters and setters. So public double get latitude, return this dot latitude. That's a getter. It allows the outside world access to your member variables. And I can go ahead and go with a setter, double void set latitude. Yeah, go ahead.
Okay, so dumb question, but in like getters, some people will have like return this dot, and some people will just do like return, or at least with tutorials I've seen, just return the variable name. And because there's not like a parameter for get latitude, it doesn't.
There's no ambiguity, but it's still best practice to use this. All right, that's why I do it, because advertising intent in your code is just as important as having your code be correct. Right? And this advertises intent way more than just this, just blind latitude here. Right? Functionally, it's the same. But this says, I understand that I'm returning this object's latitude. Right? I've got a getter and a setter now. Why does now over here, I can still get it, but I can like get latitude. But it's much better to do something like that. And if I want to set it, fine. You can go ahead and set Lincoln's dot set latitude to 4,000. Right? So it didn't change anything functionally, but now let's change it functionally. Right? Let's disallow that kind of bad variable value. Right? This is one of the advantages of encapsulation, protection of data. Right? In fact, that's the number 2, the protection of data. I want to protect this data from bad values. So if you try to go and set it to something that's invalid, if latitude is, what's the minimum valid latitude that you can have? 90 degrees south. Right? 90 degrees north, that's the North Pole. 90 degrees south is the South Pole, right? Or latitude is greater than 90, then nope, I don't want you to do that. If I don't want you to do that, how could I? You gave me something bad. I'm going to throw it back at you as an error. Throw a new illegal argument exception. Latitudes must be on the scale, -90, 90. There you go. There. So that when I run this now, nope, you can't do that. Right? Latitudes must be on the scale of 90. And the only way that I could do this is by creating getters and setters. There's still a problem though. Lincoln dot latitude. There's nothing to stop me from doing it, from circumventing my getters and setters and just doing it directly. So we need a way of protecting data. What I'm going to do is I'm going to make these private. And copy, paste, or private. There we go. Now they're all private. And you can see from the other demonstration here that you are no longer allowed to just blindly set it. You have to go through the getters and you have to go through the setters. And that basically protects your data inside your class. It's not protection as in like security protection, it's design protection. So that you do not have to test for the eventuality that somebody is going to set this to some insane value like 4,000. You've taken care of that in the design by, now you do have to maybe test this setter right here, but you are assured that if it passes all your tests in a production system, that it can never be an invalid latitude value here. Cut, paste for longitude. Longitude is going to be -180 to +180 though, right? Maybe what might be an invalid value for name? Null, disallowing null, right? Disallowing a GPS, or maybe an empty string, right? Maybe that's bad values. You can reject all those values. But it's only possible through strong encapsulation, the protection of your data. Right? Okay, again, cut, paste, cut, paste, cut, paste, or go up to source, generate getters and setters, and you can expand these out here. I'll go ahead and select all, and that gets the job done. Didn't have to type a single line of code. Right? And everything over here, well, I have to change everything over here. Dot get GPS ID, dot get latitude, dot get longitude. Right? And now, again, I'm not allowed to do this. I won't do that anymore, though. Right? Okay. Oh, what's your problem? Oh, thank you. There we go. Save it. Now that should go away. It's still complaining about these, but at least it's not complaining about these. Right? So I've opened up I've basically given you a way to access everything and a way to change everything if you want to, but I've also protected my variables up here. Right? Now I'm rethinking this design. Maybe I don't want to worry about invalid values at all. Maybe I just don't ever want you to be able to change them at all. Right? No setters. In other words, once an airport is created, you can never change its name. So you can get its name if you want to, but you can never change it because I threw out all the setters. I made these all private. You can never change the latitude. You can never change the longitude. How have I designed my object now? You can't change it once it's created. What do we call that? It's what? Not const. Close though. You can't change the internals. If you want strong const, then it would be final, 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 final. Strings. Strings are. Can you change strings once they're created? No, they are immutable. I have made my class immutable. Immutability is a very, very good thing because it gives you thread safety automatically. Right? All right, so I like that design so far. We have achieved number 1. We've achieved number 2, the protection of data. Now let's talk about number 3. Before we do, though, let's address one thing over here. Printing. All right, that looks pretty good. Go ahead and change this and then change all of these to Omaha. Omaha, there we go. Still repeated code though, right? So, suggestions on cutting this code down even further. Yeah. Let's take care of this in the class. Let's make a public string toString method. Right? Push buttonitis. Guess what? Source toString. This one's not as useful because it gives you something that looks like this. Auto-generated code is not going to read your mind and think, they wanted it formatted in a certain way. It's just going to give out this formatting here. But let's use it. Let's see what it looks like. It's a good starting point. Instead of all that, I'll just print Lincoln. Instead of all that, I'll just print Omaha. What does it look like now? Well, it looks like that, right? All it did was a bunch of key value pairs of all this stuff. That's what it auto-generated. Right? So it at least gives you a starting point. If you're going to debug, maybe that's useful. But of course, I probably want to format this a little bit better. Let me go ahead and go with system.out.printf. Right? Let's use printf style formatting. Let's print this airport's name, its latitude, its longitude, and its GPS ID. There we go. All right. And then %s. And then in parentheses here, I'll put those two out accurate to 2 decimal places, separated by a comma. And then in square brackets, I'll put the GPS coordinates right there. Right? Now, it's not going to let me do this because do you always want to print to the standard output? No. Sometimes you want to print to a file. Sometimes you want to print to a wire, as in printing it to a socket, which is a file, so that you can send it on to the CSE server or for whatever reason, right? All right, I don't want this then. I want string.format, and I want to return it. Same exact functionality. You get printf functionality out of this, but instead of printing it to the standard output, it prints it to a string. We had this in C. Do you remember the function? Fprintf would be to a file. If you want to print it to a string, sprintf, exactly. So this is basically sprintf, but for Java. And when I run it, now I get that nice formatting. If you wanted columnar data, right, data that was in columns, then you could get that for free by using this toString method, right? That looks a lot cleaner now, right? Much, much better. I'll leave that uninitialized object there just so that you can reference it, right? Okay. Another way of changing, let's say Lincoln Municipal Airport. Or maybe, no, what I did this morning was I said, I want a Lincoln Airport, but I want to move Lincoln Airport. I'm going to take Lincoln Airport and I'm going to move it east a few degrees so that now it's in Iowa instead, Epley Airport. What I could do is I could create another copy of it. Omaha moved, right? And then let's move it east 5 degrees. I assume that that's somewhere in Iowa, right? Right? Yeah, that's going to be moved east, okay? And then let's print that out. Omaha moved. There we go. But I didn't change anything else, did I? So again, why would you want to move an airport? I don't know. But I want to do something like this. Let's write up a constructor to do it for me. This is going to be a here, you give it a name after I show you what it looks like. Public airport. I don't want it to just take all 4 of these things. I want it to take all 4 of these things and make a copy, right? Well, to do that, I don't want all 4 of those things. I just want another airport. That airport. I want to copy that airport over into this airport, right? And I could do something like this. That dot, that dot, that dot, that dot. There we go. Or, following the same pattern that I should have been following like this, I could have had that dot name. This is a little bit better. That dot GPS, that dot latitude, that dot longitude. There we go. That's a little bit better, improved more, right? What would you call this? What kind of constructor would you call this? What's it doing? It's making a deep copy. But we just call them copy constructors, right? Omaha. There we go. Now this is just going to be a pure copy, right? But if I go and make internal changes and rename Epley or something like that, then only the copy will get the changes, right? This is a nice copy constructor. What if I wanted something else? And you're going to want something else for your project coming up here, probably. What if I want? Now this is a pure copy constructor. It copies everything. What if I wanted to copy that that airport, everything in that airport except for maybe the name? I wanted to change the name. I didn't want that name. I just want that name. Right? It gives me a way of creating copies and modified copies so that you can move it. I guess instead of moved, renamed. And we'll pass in Omaha, and Omaha's airport's new name is what? Scott Frost Airfield. Right. If he wins, right, then he'll have an airport named after him. There we go. Now the copy has that name, but the original is unchanged. Why? Because it's immutable. I can't change it. So nice little patterns to follow all over here. Pure copy constructors. We don't call this an impure copy constructor. There's nothing wrong with it. It's not tainted or anything like that. But it's a hybrid copy constructor. I don't know if anybody uses that. Now, why would this be nice pattern to follow? Think about a list. of integers. Right? Foo is equal to new array list of integers. And then foo.add 10, foo.add 20, 30. I want a copy. I want a deep copy of this thing. Bar. Well, I could go through and copy that one over, copy that one over, copy that one over, or I could pass in foo. So that if I change bar dot add 40 and print these both out, system.out.println foo and bar. Oops. There we go. After I get it done complaining by importing stuff. What is that? That is a deep copy constructor. This is a constructor right here. Right? By passing in another collection, it's doing a deep copy constructor for you already. Deep copy constructors. Right? All of the collections have them because it's such a useful pattern to follow. So you might find it useful. I'll go ahead and leave that in there, but comment it out since I don't want to focus on it. But it's a good pattern to follow. Right? Copy constructors. Lots of constructors, lots of constructors. All right? At this point, one note. You should always document all of your classes. Right? This class models on airport. Right? So let's have a discussion, argument, whatever. Should you document, as in write documentation for all of your constructors? If you were to release this in the real world, yeah, maybe. But for this course, no. Constructors are straightforward. That's boilerplate stuff. Boilerplate stuff probably does not need to be documented unless you're doing something screwy. Like, for example, the name is not allowed to be null. Put that in documentation. The latitude is not allowed to be beyond -90 and +90. Put that into the documentation, right? And if you do that, then you probably only have to document the main one here, right? So the name of the airport may not be null. But of course, you're going to have to actually implement a throw statement here. Do you have to do the getters? Documentation for the getters? This returns the name of the airport. Is that a useful comment? Probably not. All this boilerplate stuff does not need to be documented. The class should be documented, but only non-boilerplate methods need to be documented. And that takes us to the last thing, right? Number 3, the grouping of functionality that methods that act on that data. So tell me about this class. Does it do anything? No, it just is. It's a data. It's what we call a data container or a data class. And sometimes that's all you need. If you just have a collection of data and a bunch of getters and setters, fine, so be it. But I want some functionality here. If I've got 2 airports, what might you want to know about these 2 airports? The distance between them, right? So my goal for the next goal is to compute distance. Now let's go back to C, or let's live in a world without object-oriented programming. What might that look like? Public, static, double, get air distance. Right? Distance, right? And it takes a latitude A, double lat B, or ln A, a double latitude B, double ln B. Right? In other words, it takes 4 numbers. Do you see anything dealing with airports here at all? No. Does anybody remember the spherical law of cosines? Okay, don't worry. Oh, do you?
Yeah.
Oh. LH what?
For the never mind. For the learning assistant thing, we have to do it. But
Oh, whoa, really?
yeah,
that-
I reused it.
Okay.
But I believe it's arc cosines. I don't know what that is in Java. But probably math.a.
Math.a cosine.
And then it's sine of latitude A
Ln
times
A minus ln B. Okay.
It's
Oh, wait,
sine
was
of
A or B?
What?
Ln B minus ln A, right?
Yeah. So
Okay.
there's a change in longitude.
Lat
goes
A.
lat A, lat B, and then it'll be cosine of lat A, lat B.
Times cosine times cosine of delta, where delta is the difference in the longitudes, times the radius of the airport, or airport, radius of the Earth, which is 67.1. There we go. All right. There's my first iteration of this. All right. Any object-orientedness to this at all? Like if I just looked at these 4 lines in isolation, do you see any airport objects? No, it's just numbers. Right? So let's try to improve this a little bit. Just a little bit for now, and then even more later on. Static double get air distance. Let's not have just 4 numbers floating out in the ether. Let's have airport A and airport B. Right? Now, what that looks like internally, well, help me out. What would it look like internally? Call get air distance of A dot get latitude, A dot get longitude, B dot get latitude, B dot get longitude. Right? Code reuse, that's good. Okay. And return. There we go. Little bit more object-oriented. In other words, at least I'm talking about objects now. Right? Let me go ahead and collapse this. And from the outside world, do you have to worry about numbers anymore, other than the return type? Nope. You can say, I've got an airport, Omaha, and I've got an airport, Lincoln, and now all I need to do is pass those into the function, and I get my answer. Double distance is equal to airport, get air distance of Omaha to Lincoln. Lincoln to Omaha would be the exact same thing, right? And then system.out println dist. There we go. Well, is it 6,000 kilometers between them? What did I forget? Arc cosine, sine, cosine. What do they operate in? Radians. So I probably want a public static double degree to radians, double degrees, and then return degrees is going to be degrees divided by 180 times math.pi, right? Okay. And then I would want to incorporate that here, but of course I'm a lazy developer, so what do? I put in a to-do, fix this to use radians, right? Or I'm the ultimate lazy developer, and I commit this to the repo, and then I tell the junior developer, go through and take care of my to-dos for me. I let somebody else do it, right? All right, well, that's at least a little bit of object-oriented, right? Down here, I only have to worry about an object. I don't have to worry about math. I don't have to worry about numbers anymore. I'm closer to the real world. I've got this thing that represents Omaha. I've got this thing that represents Lincoln, and I can hand these off to a function without ever having to reason about numbers. Let's take it a step further, though. What was number 3 again? The grouping of functionality methods that act on that data. Think about this, this design right here. All right? This is still not an ideal design because I've got my objects, and inside, what I have to do is I have to rip open my objects, pull out those 2 numbers, and then hand them off to somebody else. All right? Whereas this is functionality that operates on the data that's inside of that class. So if you've got a function or a method that operates on data inside of a class, where does that method belong? In the class. Right? That's encapsulation. That's the number 3 of encapsulation. I want an actual functional piece here so that it's not just a data object anymore. I want a public double get air distance. Right? Now, what would that look like? How many airports do I have in the following context in on line 66? I know of one airport, this airport. Right? What about that airport? I want to know the distance between from this airport to that airport. You are going to have to pass in something. Airport, that airport. Right? That is a terrible name. We'll come back and fix it in a second here. Right? So what I'm going to do is I'm going to take, I still need to fix it, but I'll take that functionality that was located outside the class and put it inside the class. Now, of course, I need to change this. That dot longitude minus that, or this dot longitude, and then A is this, so this dot latitude, and this one needs to change as well, and then that dot latitude, and I will change the last one as well. Right. You might be asking yourself, wait a second, those are private methods, or those are private variables, right? How did I get away without using the getter? Because it's inside the class, exactly. A class can see other instances variables, right? So there's no protection from one instance to another instance other than using the patterns that I just showed you, making everything private. And even then, inside the class, you can muck with them as much as you want. If you wanted to make sure, absolutely sure that they were immutable, final on everything, right? Now, there's still a problem here. Should I ever have just a number pulled out of the air like that in my code? No. Now, there was a good question from earlier today. Somebody asked, well, when do I need a variable name? When should I have a variable constant, and when should I just have the number? And the example that I gave him was, if you're multiplying by 0.5, is it a good idea to put that in a variable called half? Probably not, right? It's self-explanatory. But 6371, what is that? The radius of the Earth. Right? If I didn't know the context, I wouldn't know that. Radius, or Earth radius, let's say. Earth radius. Right? Now, where does that variable belong? Double Earth radius equals 6371. Does it belong as a local variable like this? Probably not. Every time I call this function, this variable will be created on the call stack. Not that big of a deal efficiency-wise, but it is something to be aware of. Why are you doing it like that? Right? All right, well, maybe it belongs to the class, right? So that's the lowest level. Let's promote it up a little bit. Let's promote it up to the class. Now, what's the problem here? Yeah.
Well, I mean, for one thing, it's mutable.
Oh, it's mutable. We'll take care of that in a second. But it's also a member variable, right? Now, maybe we do want it to be public here because, oh yeah, I want everybody to know what the Earth radius of the Earth is, right? But the problem is it's a member variable. If Omaha will have its own copy of the variable. Lincoln will have its own copy of the variable. O'Hare, even if it's uninitialized, will have its own copy of the variable. Just like I don't want to create this variable every single time I call a function, I don't want to have this variable every single time I create an object. So let's promote it up even further. Do you remember the keyword static? Of course, because it's on main all the time. Static means that it's no longer a member variable. That member variable, or that variable, now belongs to the class, and there's only ever one copy of it, right? So public means anybody can see it, which is fine. You might want to know the Earth's radius. If you don't like that, then fine, private, right? But there's no reason to hide it. Just like there's no reason to hide pi, math.pi, math.e, right? Static, so that there's only one copy and it belongs to the class. Now, when I access it, it's okay to do this, but airport dot. That's how I should really be accessing it. Class name dot, because now it belongs to the class. You'll note that it is italicizing it. And by the way, what convention did I use on this name from the very beginning? Because I knew that I was going to make it static. All uppercase underscore casing, right? So there's still one problem, and that problem is you can change the Earth's radius. In fact, I did it this morning. I said, what happens if we do Earth radius equals there? What have I done to the Earth? I had to ask for the pronunciation, but everybody knows what the Schwarzschild Radius is. No? You don't? Oh, no, no physics enthusiasts? All right, so if you take a mass and if you compress it down far enough, if you compress it past the, no, the Schwarzschild radius, yeah, if you compress it down to past the Schwarzschild radius, it becomes a singularity in a black hole, right? So if you have a lot of mass, you don't need that, I mean, you still have to compress it down to like your hand or something like that. But if you have the Earth, which is small mass, astronomically speaking, then you have to set the Schwarzschild radius very, very small, and that's how you can turn the Earth into a black hole. Right? But should we should we be allowing that? Probably not. So how can I address it? Final. Final keyword in Java makes a variable into a constant. That any attempt to change it after the fact, I'll show you that it's a compiler error now, 0.011. Right? The compiler will not allow you to do this because once you've set it up here, then it can never be changed. That's how you make a constant. And in the math class, I'm sure that there's a public static final double pi set to 3.14159, blah, 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 blah. Right? Okay, good. Well-designed object so far. How do we actually use it now? Right? So instead of capturing this distance by doing this, it's a very subtle difference. Omaha dot, get air distance, and then we pass in Lincoln instead. Right? Now you might be thinking to yourself, big deal, right? All you did was change it so that that it's now in the class, and you reduce the number of parameters by 1. So what? It makes a huge difference when you get into more complex stuff, design-wise. Not functionality-wise, but design-wise. Right? Especially when we get into, say, collection data structures, like lists. How do I add something to a list? I just add it, .add. Imagine if the add method was located outside the class. What would I have to do? I'd have to call add to list, give it a list, and give it the thing I want to add. Right? That seems really, really icky. Right? This is way more natural. When you talk about an object and the methods that act on the data in that object, where do they belong? They belong in the object. Otherwise, you're programming in C style everywhere, right? The structural style instead, where you end up passing all of your objects all over the place, right? The grouping of functionality that acts on that data, right? Breaking encapsulation would mean breaking any one of these 3 guidelines. I don't want to call them rules. They're not hard and fast rules, but for example, don't even define a class, right? You just have 4 variables that have no relationship to each other, right? That's terrible, right? That's obviously terrible. Protection of data, making all of your stuff public, right? That's not as terrible, but it's still terrible, right? Because there's less your code is less predictable. It's more brittle then. And the grouping of functionality that acts on that data, right? Slightly less terrible still, but again, you still want to do it because it's best practice for object-oriented programming. Okay? There is a nice, well-defined object. 2 more design principles that I want to share with you. So I want to now change this object so that it has an address. I want to send a letter to the folks at Lincoln Municipal Airport and complain about their baggage claim line, right? They lost my luggage. I'm going to write a stern letter and I want to send it to them. What do I need? What do I need to send them a letter? We're talking an old school letter, snail mail letter. All right, say it. An address. Well, what is an address? A street? Oops. What else? City? State? And zip? Oh, country? Okay. You want to go full country? Right. I'll just keep it simple. Right. Is that a nice way of doing it? Is that, where am I? I am an airport, right? What is this? You called it an address. Is an airport an address? No. Is an address an airport? No. That doesn't seem like it's the right relation. What is an address? It should be its own object. For time consideration, done. And again, to review what would you have done, I would have taken these 4 lines here, copied, pasted, then all I would have done is gone up, generate getters and setters, generate, oh, I didn't, yeah, I did. Generate constructors. Generally, constructors should go first, and then getters and setters, and then the toString method, right? And a couple more standard methods that we're going to skip for now, okay? Now I have private address, right? Go back and refactor. Maybe I want to roll that into one of the constructors here, okay? Because it is warning me that you're not using this, you're not setting it, you're not doing anything with it, okay? Second design principle, or no, the same design principle here, but now I want the date that it was built. Private date built, right? Or date opened or christened or whatever they do to airports, right? So what's a date? A year, a month, and a day. So let's go ahead and build our own object, right? New class date. Right? What's the first question you ask yourself when you're doing problem solving? Is it already solved for us? Right? Take an off-the-shelf solution. So let's take that and that same idea, and what's the first question you should ask yourself when you're designing an object? Yeah. Does it already exist? So does it already exist in Java? Local date with one L. Right? There we go. Import it. No, not create class. It should be local date. Come on. Yeah. Give me. There we go. It choked for a little bit. Java.time.localDate. Right? And you can create local dates. I won't do it here, but I'll just show you really quick. Local date dot value of, or dot, that's of, there, not value of, but of. Today is 2020, it is January, and it is the 30th. There. This dot date built. It's not the day that it was built, but there. Right? It's immutable, right? It doesn't have construct. They actually took another design pattern and decided not to even make the constructors public. Instead, you can only construct them using these factory functions. This of. If I tried to say this dot date built is equal to new local date, there are no publicly available constructors at all. They want they have even they have different controls that they followed a pattern of making them all private, and then you have to create them through these static methods. You can tell that it's static because it's doing the italicization right here. Right? And of course, you can also hover over it to find that, in fact, it is static. Okay, it's not saying it here, but it should say it, but it is static. Right? So that if you try to do, say, February 30th, this will only work if I actually call it. And let's run this, and you see, invalid date. There is no February 30th. Right? There is no 13th month, 13th day. Yes, there is. What is it called? What's the 13th month? No Simpsons fans, apparently. Okay. Smarch? Yeah, Smarch. Smarch is the 13th month. And what was today? 30. There. Okay, I'll fix it. Right. There we go. All right. So, design principle. Look for objects that are already there. For example, string. Did I roll my own string object? No, I used what was it built in. That's composition. That an object, airport, is composed of other objects. It's composed of two string objects, two primitive types, and then an address type and a local date. And an address type is also composed of other objects, strings. Composition. Right? Composition follows a has-a relation. Like we said before, an airport is not an address. An address is not an airport, but an airport has an address. Does an address have an airport? No. So we wouldn't do composition the other way. That would look extremely weird, right? That would look like this: private airport, airport. There's composition the other way. That doesn't make any sense. Right? You can do it, but it doesn't make any sense. Right? All right. So I'm just going to go ahead and grab these, make sure that they're in the notes, and go over them really quick in the last 10 minutes here. Java is a class-based object-oriented programming language. This is all we went over today. Everything is a class in which you instantiate instances of it, or it belongs to a class, in which case it's a member variable or it's a static static member, in which case you use the dot operator no matter what. Right? In Java, instances are created using a constructor. By default, a no argument constructor is provided for you. The second that you define your own constructor, the default constructor goes away. You'll observe that in lab next week. Right? You can define any number of constructors you want. They have special syntax. There's no return type. The name has to match the class name, etc. Don't bother typing, getting push button syndrome or whatever it is. Right? Go from source to generate constructors using field. Source, generate getters and setters. Source, generate toString method or whatever. Right? In Java, encapsulation is achieved with the visibility keywords. Public, that's not the default, but public, any piece of code can see the variable. That effectively makes all of your variables into globals. Globals are evil, don't do it. Right? Because if you have global variables, anything can change it. You have to test for the eventuality that everything will change it. Protected, that's something that we'll go over later when we do subclassing and inheritance, but only the class and its subclasses can see the variable. Private is what we use though. Only the class instances can see those variables and thus change it. Generally, you should make all your variables private unless there is a very good reason, and that's my own personal acronym there, VGR. Very good reason to do otherwise. Right? Use composition to its fullest. Instances can own instances, can have, in other words, you typically use the term own instances of other classes as member variables. Ownership is a little bit dicey when it comes to Java because it's there's no memory management. It's more important in a programming language like C++, where you have true composition versus association versus something else, but you don't have to worry about those distinctions in Java. Right? Composition refers to has a relationship. An airport has an address. Right? Careful, don't over-engineer your objects. For example, if I were to do a person object, a person has a name, a last name and a first name. Wait a second. They also have a middle name. Sometimes they have two middle names. I have two middle names. All right, so for this just says I need to make a name object because they also have a title and a suffix and a preferred name, right? So getting now I've got 7 objects. I should make a name object. Okay, only if you're going to need it, right? And generally, Yagni, you ain't going to need it, right? That's what that stands for, right? Don't over-engineer your objects. Example, a name can hold a half a dozen strings, but there's no reason to unless, and like I said in this morning's lecture, sometimes you'll have business folks come to you and say, yes, we need to support all these things. And okay, yeah, sure, we'll go ahead and do that. And then you go back to your team, Yagni, but keep it on our backlog or whatever. If they come back in a week and say, we told you we needed these things, then okay, they probably really needed these things and we'll do it, right? And if they forget about it, then yeah, you can forget about it too, right? You ain't gonna need it, and I proved you right. Right? Don't over-engineer your objects. Don't future-proof everything just for the sake of future-proofing stuff, right? Up to now, all of our objects were data containers or holders, but the third part of encapsulation, make your objects functional, right? In general, any method that acts on an object's data belongs in the object, or in the class, I should say. Right? Okay. All right. Any questions so far? No? That's more than enough to do even the first phase, the first design phase for your project. If you have not done so already, make sure that you've gotten a very good start on homework 1. It is due tomorrow at midnight. I did take some stats in the main section. I think that 70% had submitted at least one thing. I didn't take stats for this section, but again, make sure that you're getting a good start on that if you have not already. Because of course you'll want to go over and play Smash Brothers from 12 to 3 tomorrow instead of doing coding. But also, next week we'll take a little break on Tuesday because we'll have some special guests come in from the Writing Center, and we're going to talk about how coding is really no different from writing. Right? Well, you're writing code, right? There's no difference at all, right? No, drafting, right? When you are writing, say, an English paper, or even a creative endeavor, if you're writing a play or a poem or something like that, you go through several drafts, and that's exactly what you should be doing with your code. Even if it's functional, you go back and redraft it, clean it up. We call it refactoring, right? Next week on Friday is your first draft of your design document, right? So that's why I'm having them come in and we're giving a special lecture on technical writing, basically. Okay? All right. See you on Tuesday then.
Okay, so it's on the table.